Alright, subcourse 0D, OD 1650, edition 8, Welding Theory, an Army Professional Institute of Professional Development Army Correspondence Course Program, Welding Theory. Introduction. Welding is one of the most important functions within metalworking shop. Many of the broken parts may be welded and put back into service, saving the expense of fabricating, purchasing a new piece of equipment. Downtime is reduced. This task will describe the welding process to include the interpretation and identification of welding symbols used in shop drawings. 2. Welding process. General and master chart indicating the great variety of welding processes shown in Figure 1 on the following page. The term welding process means heating metal parts to the temperature high enough to join metal parts by coalency. Welding is done with or without the use of pressure by the pressure alone, or with or without using filler metal. Coalency means the growing together or growth into one body of the base metal part. There are two basic requirements for coalency: heat and intimacy of contact. This is a master chart. You can find these on the internet. Shows the welding processes. It's too small, I'm sorry. Heat. The welding process differs depending on the source of the heat, the manner in which the heat is applied, generated, and intensive of the heat. The source of the heat may be combustion of fuel gases such as acetylene, hydrogen in air, and oxygen in an electric arc, electric gas, or oil furnace. The resistance of metal to the flow of electrical current or chemical reaction between a metal oxide finely divided aluminum. The intensity of the heat applied generated with the joint varies according to the welding processes used. A welding process is set for brazing using temperature high enough to melt the base metals. Brazing is one of the welding processes in which melting of the base metal is not necessary. Coalency is similar to soldering except that as higher temperatures are used. The term soldering is used to describe joining processes with non-ferrous filler alloy metals below 800 degrees Fahrenheit. Soldering is not considered a welding process. Brazing is a welding process using non-ferrous filler alloys that have melting points above 800 degrees Fahrenheit but below that of the base metal. Intimacy of contact. The second basic requirement of the coalency is the intimacy of contact. May it be divided into two groups: pressure process, non-pressure process. In pressure process, intimacy and contact is achieved by applying pressure while contact surfaces are high enough to temperature to alloy plastic flow of the metal. In the non-pressure processes, the space remains between the surfaces to be joined. The space is then filled either with aggressive or all at once molten metal. Molten metal may be obtained by from a filler metal welding rod electrode. Metal surfaces to be joined by combining a filler metal or metal base metal. All non-pressure processing involving fusion, they are often referred to as fusion processes. However, the term is somewhat misleading since some of the pressure processes also involve fusion. The various welding processes differ not only in the way of cohesion as achieved, but is also in the variability to produce satisfactory joint and given the kind of the metal under the conditions which the weld must be made. Many factors influence the selection of the welding process for a particular application. These factors include relative cost, the amount of welding required, location, position of the welds, the service condition of the welding structure, and must withstand, and the qualifications of the person who does the welding. Probably the most important single factor is whoever is the weldability of the metal. Weldability. The term weldability means the capacity of a metal to be fabricated by a welding process into a structure that will perform its purpose satisfactorily. Weldability also means the degree of simplicity, complexity of the procedure techniques necessary to produce welds and properties that are equal to better than the properties of the base metal. For example, mild steel can be welded by most welding processes, but welds produced are not equal satisfactory. One of the methods may be more complicated, more expensive than the other. While it is possible to weld mild steel through the use of variety of welding processes, some of the metals, such as aluminum and its alloys, can be welded satisfactorily through only a few welding processes. Mild steel does not require elaborate preparations, fluxes, special techniques, because its characteristics are such that the welding operator can be easily made. Other metals require special preparatory steps, complex welding sequences, skills, use of specific welding technique, extensive heat treatments after welding. Many factors influence the weldability weldability of a metal. Some of the important ones that must be taken into account insofar as the possible is controlled are many of the factors influencing the weldability of the metal. Some of the important ones that must be taken into account so far as is possible controlled. One, the chemical composition of the metals involved. This is kind of the percentage of the elements present and the effect of the radical temperature changes of various metals. 2, the expansion and contraction characteristics of base metals. 3, the filler metal welding rod and electrode. 4, the joint design. And 5, the welding procedure. In steel, carbon is probably most important element in that limits weldability. Carbon gives the steel hardenability that was certain carbon steels are heated with a critical temperature they haven't cooled rapidly. They become much harder. At the same time, they lose ductility. In fact, the metal has become so extremely brittle, and with a few exceptions, the temperature used welding exceeds the critical temperatures of carbon steel. Furthermore, hardening may occur with the mass relatively cold cold metal surrounding the welding area conducts heat away so far that the rapid cooling occurs. Thus, certain steels may become hardened by many welding processes. When the percentage of carbon is less than 0.25%, it's an effect of producing hardness and slight. When the carbon extent exceeds 0.25%, when the element magnesium, vanadium, chromium, molybdenum, titanium are present together with the carbon percentage at less than 0.25%, weldability of the steel is, and special steps which should be taken to control the preheat, interpass temperature, post-heat welding sequence. Otherwise, satisfactory welds will likely to crack and to have reduced toughness, less strength than required. For the reason tools, steel, certain alloys like carbon molybdenum steel are less weldable than any other steels. Steels contain certain impurities such as sulfur, phosphorus, hydrogen, nitrogen, and oxygen. If present large enough, the quantities of these impurities may decrease weldability. For example, steel to which about 0.1% sulfur has been added to improve the machinability difficulty of weld because the weld has a tendency to crack. An excessive amount of the phosphorus decrease the ductility of the steels and decrease the weldability of the metal. In the presence of hydrogen, steel, filler metal, and flux may lead to cracks in the weld. Stainless steel, high chromium steels, and other special steels are less weldable than plain carbon steels. The element that gives these special steels the desirable properties for specific applications also has the effect of decreasing the weldability of the metals. To make these special steels weldable, the welding procedures of the filler metal, the fluxes, preheat, and post-heat temperatures, the welding sequence must be carefully selected. There's also true but many nickel, copper, aluminum alloys, and some metals. The heat of the welding process may cause certain elements with low melting points to vaporize, reducing the amounts of the elements present in the weld zone. Non-ferrous alloys contain lead, zinc, and tin are particularly subject to such losses from vaporization. These losses may seriously affect the properties of the joint by causing porosity and oxide inclusions in the weakening of the weld. The weldability of a metal is affected as in thermal conductivity. In general, metals with high thermal conductivity are difficult to weld because they transfer heat away from the weld so rapidly that the required temperature cannot be maintained at the joint. Changes in temperature cause metal to expand, contract. These also affect the weldability. When metals expand and contract in different rates, the internal stress sets up these changes and can cause joint to crack immediately to crack later under the load. Even when welding joints identical metals have approximately the same coefficient to expansion. The expansion and the contraction may not be uniform throughout all the part of the metal. These deficiencies lead to internal stress, distortion, and warping. Metal parts must be free to move. Special welding sequences must be used. The heat is applied with drawn expansion contraction set up to the high stress, which may cause trouble in the weld itself. The adjacent base metal in the material's uneven expansion contraction may cause metal to warp. In heavy materials, the stress set up when they exceed the ultimate strength of the metal and cause cracking to occur in the weld. The metal may next to the weld, which is called the heat affected zone. Even the ultimate strength of the material is not exceeded by the stress developed during the welding. Combination of welding stresses plus stress developed in the material is placed in service, but may be enough to cause the failure of the weld. For this reason, many materials are stress relieved after welding. Another factor influencing weldability: the filler metal, the wrong electrode, or an incorrect welding process will make the welding difficult and impossible. It may lead to failure to part of the under service conditions. It's not always essential for that a welding rod or electrode be the same chemical composition as the base metal. The important requirement of the combination filler metal and the base metal will make a satisfactory welded joint. In some processes, the flux selected with the using of the welding rod has an important effect on the weldability. Also, the electrode covering the influence weldability. Certain steels, molten steels, have tendency to absorb hydrogen from the surrounding atmospheres to expel that it will solidify. Some types of the electrode covering send a lot of hydrogen into the atmosphere surrounding the arc and molten puddle. The hydrogen is enough to cause a microscopic crack in the heat-affected zones of some steel. To eliminate the problem, low hydrogen electrodes have been developed to weld near higher tensile steels. Design and influence the weldability of the metal. Several factors must be considered when selecting the joint design. They include welding process, thickness of the material, and to be welded, and the purpose of this joint is to serve. Thin sheets of the metal can be butted together without special preparation or other cleaning, but heavy plates must be beveled and grooved to make a satisfactory joint. Again, the design is used related in the purpose that it is weighted the load of the stress is applied to the erosive or corrosive conditions it may resist. Joint efficiency and the joint efficiency. The term joint efficiency is used to indicate the strength of a welded joint as compared with the strength of an unwelded base metal. Each welding process has techniques, procedures peculiar to the process. Often the technique varies with the kind of size of the filler metal used and the kind of welding being made. In the incorrect use of technique, the use of the wrong technique may lead to the defects, making the joint unsatisfactory. The conclusion, the information of the welding process provided with a brief introduction of welding. A shop drawing is a universal language used to convey all necessary information that an individual would need to perform the welding process. Special symbols are used to furnish the shop drawings to show the kinds of welds to be used. The following subparagraph will contain the data used in the function of the welding symbols. 3. Welding symbols. Generally, welding symbols provide the means of placing complete, concise welding information on the drawing. The reference of the line welding symbol figure 2 is used to designate the type of the weld to be made in location, dimension, extension, contour, or other supplementary information when necessary. A tail is attached to the reference line which will provide such notations. When such notations are required, the tail is omitted. This is your standard location of the elements, starting from the arrow backwards, the weld around the symbol, arrow connection of the reference line to the arrow side of the joint, the grooved member, or both. The field weld is at the point of the arrow meets the and then the switch center of the center spacing is marked with a P, length of the weld with an L. The groove, the angle included the angle, the countersink of the plug welds is filled with an A with the finish symbol on the place over a contour symbol. The right is the root opening of the depth of the filling of the plug, and the slot and the weld is in the middle. You have your arrow side and your other side, and both sides of the basic welding symbol detail reference. The S stands for size of the strength of the resistant welds, the reference line, specification process other than reference, and the tail may be omitted when reference is not used. Elements in this area remain as shown, and with the tail and arrow are reversed. Elements of the welding symbol. A distinction made between the term welding symbol and the welding symbol. Weld symbol and welding symbol. The weld symbol is an ideograph that is indicated by the desired type of the weld. The assembled welding symbol consists of the following 8 elements. Of these elements, there are necessary reference line, arrow, basic weld symbols, dimension, other data, supplementary symbols, finish symbols, tail, and the specification process or other reference. Location of the elements of the welding symbol within respect to each of the shown in Figure 2. So from the left, you have your fillet, your plug shot, your arc spot and arc seam, your square, your V, your bevel, your U, your J, your flare V, your flare bevel, your bead type or your melt through, your bead type, surfaced, flange, corner. You have your field type of the welds, resistant spots, projection, resistant seam, flash or upset, and supplementary symbols, weld around, shield weld, flush, or convex. Basic weld symbol. Generally, weld symbols are used to indicate the following welding processes used in the metal joining operation, where the weld is localized all around the shop of the field. The contour welds, the basic weld symbols are summarized in paragraph 2 through 5 below the illustrated with the figure 4 of the following page. Arc and gas welding symbols. The symbols are used and shown in figure 3, view A. Resistant weld symbols are shown in the view figure 3, VB. Brazing and forging, thermit, introduction, flowing welding symbols. These welders are indicated by using the specification reference to the tail welding symbols shown in figure 4, view B. View A, when the definite process is required. Figure 4, view B. The process may be indicated by one or more of the legit letter designations shown in table 1 and 2 following the pages. When no specification process or other reference is used in the welding symbol, the tail may be omitted. As shown in figure 4, view C. The supplemental symbols. The symbols are used in many welding processes and will be shown in figure 3, view C on page 9. The other member of the joint will be considered the other side of the member, as in views A and B of figure 6. On the following, when the joint is depicted on single line drawing and the arrow welding symbol is directed on this line, the arrow symbol of the joint is considered the near side of the joint in accordance with the usual conventions of the drafting. Figure 5, view C and D. When the joint is depicted in the area of the parallels of the plane projection and the drawn and the arrow welding symbol is directed in the area, the aerial side member of the joint will be considered the nearest member of the joint in accordance with the usual conventions of the drafting. The process specifications. At the top, you have your process specification reference. Below that, you have your definite preference reference. Before that, underneath that, you have no process identification reference, and then you have a weld all-around field and field weld symbols. In the bottom here, you have a resistant spot or resistant seam weld. Welding processes: torch brazing TB, twin carbon arc brazing TCAB, furnace brazing FB, induction brazing IB, resistance brazing RB, dip brazing DB, block brazing BB, and flow brazing F1 FLB. The flow welding is flow. The resistant welding, flash, upset, and welding percussions are FWUW, PEW. Induction welding, IW. Arc welding, bare metal arc the arc welding, you have your bare metal arc welding, BMAW. Stud welding, SW. Gas shield studding welding, GCSW. GSSW, submerged arc welding, SAW, gas tungsten arc welding, GTAW, gas metal arc welding, GMAW, automatic hydrogen, AHW, shield metal arc welding, SMAW, twin carbon arc welding, TCAW, carbon arc welding, CAW, gas carbon arc welding, GCAW, shield carbon arc welding, SCAW, thermit welding, non-pressure thermit welding, pressure thermit welding, NTW, PTW, gas welding, pressure gas welding, oxygen hydrogen welding, oxetane welding, air and acetylene welding, PGW, OHW, OAW, AAW, forge welding, rolling welding, die welding, and hammer welding, RW, DW, and HW. The following certificates may be indicated with the method applying above the process: automated welding, AU, machine welding, ME, manual welding, MA, SM, semi-automatic, SA. Note letters designated that have been assigned to arc spot resistant spots or arc seams resistant seams or projection welds seem that the weld symbols since the weld symbols are used are adequate. Table 2, designation of cutting process letters: arc cutting in the air, carbon cutting, carbon arc cutting, metal arc cutting. The arc cutting is an AC series with the AAC for air carbon, air cutting, CAC, and metal arc cutting, MAC. Oxygen cutting is an OC series. Chemical flux cutting is an FOC. Metal powder cutting at POC. Arc oxygen cutting, AOC. The following certificates may be indicated with the method of applying for the process: automatic cutting, AU, machine cutting, ME, manual cutting, MA, and semi-automatic, SA. Location significance of the arrow. In the fillet groove of flange, flash, or upset welding, the arrow will connect with the welding symbol reference to the one side of the joint. This will be considered the arrow side of the joint. Figure 5, view A of the following page. The side opposite of the arrow side of the joint is not considered the other side of the joint. In the plug spot of the arc seam resistant spot resistant seam protection welding symbol, the arrow will connect with the welding symbol reference line to the outer surface on the other members of the joint with the center line with the desired weld, the membership to which the arrow points to the considered the arrow side member. The fillet welding denotes the location of the weld. The arrow side of the fillet below shows the arrow side of the fillet of the welding symbol section or the desired weld is section end view. The other side of the fillet shows the desired weld, and the other side of the end view. Arrow sided V groove with welding symbol. Top view desired weld. Others V groove with welding symbol. Um, Top view other welding symbol. Location of the weld respective to the joint. Welds or arrow spot side of the joint will be shown in placing the welding symbol side of the reference line toward the viewer. The welding on the other side of the joint will be shown in placing the welding symbols on the side of the reference line from the viewer. Welding theory. Welding on the both sides of the joint will be shown in placing the welding symbols on the both sides of the reference line toward and away from the viewer. Resistance spot and resistance seams, flash, and upset welds have no arrow side, other side of the significance in themselves. Other supplementary symbols of conjunction with these symbols have such significance. For example, the flush contour symbol is used in conjunction with the spot and seam symbols to show that the exposed surface of one member of the joint to be flush, and resistance spot or resistance seam flash or the upset weld will be centered on the reference line. The plug slot welding symbol is an indication of the location of the dimension of the weld. If your desired weld is your section end view for the plug weld on the arrow side of the joint. In the example B, you see the slot weld at the arrow side on the joint with the desired weld and symbol. Dimensions of plug slots welds 45 3/8 30-degree inch 30 degrees. Dimension of details of slot welds and surface contour of the plug-in slot welds. Note all the dimensions shown on the are in inches. Welding symbols indicating type of allocation of welds. Welds on the arrow side. A. Welds on the other side of the joint. B. Welds on both sides of the joint. C. Flush contour symbol spot seam flash and upset welds. Combination of welding symbols, single bevel groove, backing welding symbols, desired weld, backing of the single J groove fillet and welding symbols with desired weld, single bevel and double fillet welding symbol, desired welds. Reference in general symbols may be used without specification process of reference if the following circumstances. Note such that the following appears on the drawing unless otherwise designated. All welds to be used in accordance with the specification number of the welding procedure to be used in the prescribed elsewhere. General notes such as following may be placed in the drawing to provide with the detailed information pertaining to the predomination of the welding. Information needs not to be repeated on the symbols unless otherwise indicated. All fillet welds are 5/16 of an inch size unless otherwise indicated, but the root openings of all grooves groove welds are 3/16 of an inch. Welding around and all field weld symbols will extend completely around the joint will indicate the meaning of the weldable all around. Round symbol welding theory. Field welds are welds not made in a shop. At the place initial construction will be indicated the means of the field weld symbol. Extent of the welding denoted with the symbols. Symbols apply between the abrupt change in the direction of the weld. Extent of the hatching dimension lines, except for the welding around the symbol, is in the welding hidden. Welding on hidden joints may be covered with the welding the same at the visible point of the drawing will indicate the presence of the hiding members, and if the welding on the hidden joint is different from the one of the visible joint, specification information for the welding both will be given. Location of the welding symbols. Welding symbols except for the resistance spots and resistance seams will be shown only on the welding symbol reference line, not on the lines of the drawing. Reference spots and reference seams weld symbols may be placed directly in locations desired weld. J using inch degree and pound marks. Inch degree pound marks may be not in based on the welding symbols described, and except that the inches will be used in indicating diameter for the arc spot, resistance spot, and circular projection welds that are width of the arcs of the seam. Resistance seam of the welds when such welds are specified with the decimal dimension. Construction of symbol. Fillet, bevel, J groove, or bevel groove, corner, flange symbol will be shown in the particular leg ways, always to the left. In the bevel, J groove welding symbol arrow will point to the definite break toward the member of the chamfered, which is to be chamfered. In case the member to be chamfered is obvious, the break of the arrow may be omitted. Information of the welding will be placed read left to right along with the reference line in accordance with the visual conventions of the drawing. Construction symbols. You have your perpendicular leg always to the left, an arrow break toward the chamfered member. Your symbols placed to the reed left to right, and the special types of welds. For joints that have more than one weld, symbols will be shown for each of the weld. When the basic weld symbols are indicated the desired weld will be shown in cross-section detail. Other data, the reference for the welding symbol, observing the usual location and significance. The fillet weld dimensions of the fillet weld will be shown on the same side of the reference line as the welding symbol. When the fillet are indicated on both sides of the joint, no governing dimension of the weld appears on the drawing. Dimension will be indicated as follows: when the welds have the same dimension on one or both dimensions. When the welds differ from the dimension, both will be dimensioned. 3. When a fillet are indicated on both sides of the joint, general note the governing dimension of the welding appears in the drawing. Neither weld needed to be dimensioned, but if the dimension one of the both welds differ from the dimensions given in the general note, both welds should be dimensioned. M. The size of fillet welds. The size of the fillet weld should be shown on the left of the weld symbol. The size of the fillet will use the unequal legs as shown in the parentheses left of the welding symbol. Welding orientation is not shown, but the symbol will be shown on the drawing when necessary. Figure 9 shows fillet welds. The dimension of fillet welds. The fillet weld on a three-sided, no welded corners. Extent of the field welds, desired welds, and symbols. The combined intermittent, and continuous welds, and surface contour of the fillet welds. Length of the fillet weld. So the length of the fillet weld will indicate the welding symbol shown on the right of the welding symbol. When the fillet of the welding extended the full distance between the abrupt change of the direction of the welding, no length of dimension should be shown on the welding symbol. Special lengths of the fillet welds may be indicated with the symbols in conjunction with the dimension lines. The extent. Extent of the field welding. When it's desired to show the extent of the fillet welding graphical, one type of the hatching with or without a definite line shall be used. 2. The fillet welding extended beyond the abrupt changes in the direction of the welding will be indicated by the means of the additional arrows pointing to each of the section to the joint to be welded, except the weld or all-around symbol is used. Dimension of the intermittent fillet weld of the pitch or center spacing. Intermittent fillet weld should be shown as the distance between the center of the increments one side of the joint. The pitch of the intermittent fillet weld should be shown of the right to the length of the right of the length of the dimension. Chain intermittent fillet welds will be shown in Figure 9, View 5. Staggering intermittent fillet welds will be shown in Figure 9, View G. Termination of an intermittent field welds. When intermittent field welding is used, itself symbol indicates the incrementals were located at the end of the dimension. The intermittent field welds are used between the continuous fillet welding, and the symbol indicates the space equal to the pitch minus the length of one increment should be left at the end of the dimension length. Separate symbols will be used in intermittent continuous fillet weld when there are two used in combination. The surface contour of the fillet welds. Fillet welds will be welded approximately flat face without resource of any of the method of finishing was shown in the added flush of the contour symbol. The welding symbol observes the usual location significance. 2. The fillet welds that are to be made with the flat face mechanical main will be shown adding by the flush contour symbol. The user standard finish symbol observing usual location significance. 3. The fillet welds are to be made mechanically. To be used, the convex contour will be shown adding both of the convex contour symbol, the user standard finish symbol, both of the welding symbol observing the user location. Note the finish symbols referred to in 2 and 3 above indicated with the method of finishing: C. Chipping, G. Grinding, and H. Hammering, M. Machining, and not to the degree of finish. Alright, the plug and slot welding. Generally, neither the plug of the welding symbol or slot weld symbol will be used in designating fillet welding holes. 2. Arrow on the other side of the identification of the plug or slot welds. Holes or slots in the arrow side of the member of the joint of the plug of the slot weld will be indicated by placing the weld symbol on the side of the reference toward the viewer. Holes, slots, and other side of the member on the joint indicated with the placing of the welding symbol on the side of the reference line away from the viewer. Plug welding dimensions. Dimension of a plug weld should be shown in the same as the reference as the welding symbol. The size of the weld should be shown on the left of the welding symbol. Include the angle of the countersink of the plug. The welding should be used at the standard unless otherwise indicated, including the angle countersink. We're not using user standards will be shown either above or below the welding symbol. The pitch, center spacing of the plug of the welds will be shown at the right of the welds symbol. 4. The depth of the filling of the plug of the slot welds. The depth of the plug of the slot welds will be completed unless otherwise indicated with the depth is complete with the depth of the filling will be shown on the side of the welding symbol. 5. Details. The slot weld's length, width, spacing, including the angle of the countersink interact, orientation, location of the slot welds cannot be shown in the welding symbol. These data will be shown in the drawing, but the detailed reference to the welding symbol, observing the usual location, significance, surface contour, plug shot, and slow welds. The surface contour shall be indicated with the same manner as that of the fillet welds. T. Arc spot and arc seams. Generally, the dimension of an arc spot and arc seam will be shown on the same side of the reference to the welding symbol. 2. The size of the arc spot and the arc seam. These welds are dimensioned either by size or strength. B. The size of the arc spot and will be designated with the diameter of the weld. The arc seam's weld size will be designated with the width of the weld. The dimensions will be expressed in fraction decimal, and the hundredths of an inch will be shown with or without inches marked to the left of the welding symbol. Alright, figure 10 shows your arc spot and arc seam welds. First at the top, and you have dimensions of an arc spot, arc seam welds. B, the extent of the arc spot welding, and the number of arc spots welded in a joint, surface contour of the arc slots and arc seam welds. The strength of the arc spot weld is designated with the minimum acceptable shear strength in pounds per spot. The arc seam welds is designated with the pounds per linear inches. Strength is shown on the left of the welding symbol. 3. The spacing of an arc and arc seam welds. The pitch of the arc spot welds is indicated with the length of the arc seam welds to be shown on the right of the welding symbol view. When the arc seam welding extends the full distance between the abrupt change in the direction of the welding, no length of dimension need to be shown with the welding symbol. Extend the number of the arc spots. The arc spot extends less than the distance between the abrupt change in the direction of the welding, less of the full length of the joint. Extend with the dimensions on the previous with the definite number of arc spot welds desired with a certain joint. The number will be shown in parentheses either above or below the welding symbol. Details on arc seam welds, spacing, extent, orientation, and location of arc seam with weld cannot be shown in the welding symbols. The data will be shown in the following. The flush arc spot, arc seam weld joints to express the surface of the one of the member of the arc spot, the arc seam weld joints to be flushed. Soft surface will be indicated with the adjusting of the flush of the contour symbol in the same manner as the fillet welds. For groove welds. Generally, the dimension of the groove weld will be shown on the same side of the reference line with the welding symbol. B. When no general notation is given but the dimension of the groove welds appear with the drawing, dimension of the double groove welds should be low as follows: 1 with the bolt when both welds have the same direction, or both may be dimensioned. When the weld is in dimensions, both welds will be dimensioned. C. When general note governing the dimension of the groove welds appear for the drawing, the dimension of the double groove weld will indicate as follows. The grooving weld symbols are shown in A, B, C, D, and E for the dimension of the groove weld, and F the surfacing contour of the groove welds. If the dimension of the both welds are indicated with no either the symbol needed to dimension. 2. The dimension of one of both differ from the dimension given by the general note of the welds and dimension. 2. The size of the groove weld. The size of the groove welds will be shown on the left of the welding symbol, but by the size of the welds will not specify, but the root penetration will be shown as follows. The size of the single groove symmetric double groove welds are extended completely through the member of the members being joined, not to be shown on the welding symbol. 2. The size of the groove welds will extend only partly through the members of the being joined will shown on the welding symbol. The size of the groove weld specified root penetration, except for the square groove weld indicated with the showing of both the depth of the chamfer and the root penetration separated by the plus mark placed to the left of the welding symbol. The depth of the chamfering root penetration will read in the order left to right along with the reference line views in E5 and E5 of the previous page. The size of square of the groove welds will be indicated with the showing of only by the root of the penetration. The size of the flare groove welds and considered extended only the tangent points indicated with the dimension lines. This shows the dimensions of groove welds. You have your desired weld symbol and your of your groove, and then grooves on both sides desired. And the depth and the penetration and the root and penetration and groove dimension, root opening, groove angle, groove radii, root face of the U and J groove welds of the user standard unless otherwise indicated, but the user standard is not using the welding symbol as shown as follows. One root opening will show shown in the inside of the welding symbol. 2. The groove angle groove welds will be shown in figure 11 view E. Groove radii, root faces U, J. Groove weld shown to be across the section. Detail other data the reference to the welding symbol. Observe it, each at location and significance. Backing and backing welding symbols. A shows the back and the backing welding symbol. B shows the surface contour backing and the backing welds. C through is a melt through weld symbol, and D shows the surface contour of a melt through weld. Backing and backing weld is B-type back of the backing welds. The single groove welds should be shown by means of the back of the backing welds. Surface contour of the groove welds, contour symbols of the groove welds are indicated in the same manner as the fillet welds. Welding symbols. A, size of surface built up in the welding. B, the edge of the flange of the welding symbol. C, the corner flange way welding symbols. D, the dimension of flange welds. E, the surface contour of flash or upset. Backing and backing welds. Generally, the backing welding symbols on page 9 will be used to indicate with the B-type backing the welding of backing welding with a single groove weld. Backing welding is a single groove weld should be shown in by placing on the back of the backing welding symbol on the side reference line opposite the groove weld symbol. See the dimensions of the back of the hacking welds should be shown on the welding symbol. If desired to be these dimensions, they should be shown by the drawing. Surface contour backing welds. The contour symbol for the backing welds are indicated with the same manner as the fillet welds. W. Melt-throughs. General. A. The melt-through symbol will be used where at least 100% of the joint penetration weld through the material is required. Welds may be used from one side only. Melt-through welds should only be placing melt-through weld symbol on the side of the reference line opposite the groove wedge, flange T, and the corner weld. C. The dimension of the metal weld will not be shown with the welding symbol if the desired specified with the dimensions they are shown by the drawing. Surface contour melt-through welds. The contour symbol with the melt-through welds are indicated with the same manner as for the fillet welds. X. Surfacing welds. G. Generally, surfacing welds will be used to indicate the surface built up by the welding. When built up by the single multi-pass surfacing welds, the surface welding symbol does not indicate the welding of the joint, hence no other decided significance. Symbol will be drawn on the side of the reference line toward the viewer. The arrow will point clearly to the surface on which the weld is to be deposited. 2. The size of built-up surface. The size of the height of the surface of the built-up welding indicated showing the minimum height of the weld deposit of the left of the weld symbol. The dimension will also always be on the same on the side of the reference of the welding symbol. They have no specific height of the welding deposit desired. No size dimension needed to be shown on the welding symbol. 3. The extent, location, orientation of the surface built up by the welding. When the entire area of the plane covered surface is to be built in the welding, no dimension or other size needed should be shown in the welding symbol if and only the portion of the plane covered in the surface to be built up by the welding. Extent, location, orientation of the area to be built up indicated in the drawing. Y. Flange weights. The following welding symbols are intended to be used light gauge metal joints and joining the flaring and the flanging of the edges to be joined. These symbols have no arrows or other side significance. B. Edge flange welds should be shown with the edge of the flange weld symbol. Corner flange welds should be shown with the corner flange symbol, welding symbol. The dimensions of flange welds. The dimension of flange welds should be shown on the same side of the reference line of the welding symbol. B. The radius height and above the point of the tangent indicated with the showing of the both the radius height and separated with the plus mark and the place on the left of the symbol welding symbol. The radius of the height shall be read in the order of the right to left to right along the reference. See, the size of the flange weld should be shown in the dimension outward of the flange dimension. Root opening of the flange will be not shown in the welding symbol if and desired to specify with the dimension it was shown on the drawing. 3. The multiple joint flange weight for the flange welds and one or more pieces are inserted between two outer pieces. The same symbol as shown with the two outer pieces will be used regardless of the number of the pieces inserted. Z. Resistant spot welds. Resistant spot welds have no arrow or other side significance in themselves, although supplementary symbols used in conjunction with them may have such significance. Resistant spot weld seams will be centered on the reference line. Dimensions may be shown on either side of the reference line. 2. The size of resistant spot weldings. Resistant spot weldings will dimension on either side of the strength that follows. The side of the resistant welds will be designated as the diameter of the weld expressed in fractions, decimally on hundreds of an inch will be shown with or without inches to be left on the welding symbol. B. The strength of the resistant spot welds will be designated. The minimum acceptable shear strength of pounds per spot will be shown on the left of the welding symbol. Alright, here shows the resistant spot welded symbol. Size of the resistant spot weld 0.25. of an inch. Um, B, the strength of the resistant spot welds. C, the space of the resistant spot welds. Extent of the resistant spot weld. And E, the number of resistant spot welds and the contour of the resistant spot weld. 3. Spacing of the resistant spot welds. The pitch of the resistant spot welds will be shown on the right of the welding symbol. B. When the symbols are shown directly on the drawing, the spacing will be also using dimension lines. When the resistant spot welding extends less of the distance between the abrupt change of the direction of welding less of the full length of the joint, the extent will be dimensioned. For the number of resistant spot welds, when the definite number of the welds are desired certain joints, the number will be shown in parentheses either in above or below the welding symbol. 5. Flush resistant weld joints. When the exposed surface on the one of the member resistant spot welding joints to the flush with the surface indicated with the adding flush to the contour symbol, the welding symbol observes the usual local significance. AA projection welds. AA embellishments for the arrow side member of the joint projection weld will be indicated with placing the welding symbol on the side reference toward the viewer. B. The embellishment of the other side of the member of the joint projection weld will indicate the placing of the weld symbol on the side of the reference line away from the viewer. C. The proportion of projections will be shown in detail other suitable means. And D. The dimension of the projection welds will be shown on the same side of the reference line as the weld. Figure 16 shows the projection welds, the indicated embellishment, the section end view, and the plane elevation. The embellishment of the arrow side of the member of the joint and projection welds. B. The embellishment on the other side of the member of the joint of the projection welds with the plan for elevation, the section end view, and the indicated embellishment. Below that, you have C. The diameter of the projection welds. D. The strength of the projection welds. E. The spacing of the projection welds. Number of and F, number of projection welds. G, the extent of the projection welds, and H, the contour of projection welds. 2. Size of projection welds. Projection welds will be dimensioned as the strength. Circular projection will may be dimensioned on size. The size of circular projection welds will be designated on the diameter of the weld, expressed with the fraction decimal hundredths of an inch will be shown without inches on the left of the weld symbol. The strength of projection will be designated with the minimum acceptable shear strength in the pounds per weld will be shown on the left of the welding symbol. 3. Spacing the projection welds. The projection weld will be shown on the right of the welding symbol. The number of the projection welds with a definite number of the projection welds but desired in the certain joint, the number will be shown on parentheses. 5. The extent of the projection weld. When the projection weld extent with less the distance above between the abrupt change of the direction of the welding less than the full length of the joint, extent the dimension. 6. The flush of projection weld joints. When exposed surface, one of the number of the projection weld joints to be flush with the surface indicated by the adding of the flush contour symbol to the welding symbol, observing the usual local significance. BB resistant seam welds. A. The resistance general. A. The system resistant seam welds have no arrow other side of significance themselves, although supplementary symbols in conjunction may have such significance. Resistant seam welds will be centered on a reference line. Dimension of the resistant seam welds may be shown on either side of the reference line. 2. The size of the resistant seam welds. Resistant seam welds will be dimensioned by either size or strength of fouls. A. The size of the resistant seam will be welds will be designated with the width of the weld expressed in a fraction decimally hundredths of an inch shown below with or without inches marked on the left of the welding symbol. B. The strength of resistant welds will be designated with the minimum acceptance shear strength in pounds per linear inch will be shown left of the welding symbol. Figure 17 shows the resistant seam welding symbol. The size of the resistant seams. The B. The strength of the resistant seam weld. C. The length of resistant seams. D. The extent of the resistant seams. E. The dimension of the intermittent and assistant seams. F. The contour of resistant seam welds. 3. The length of the resistant seam weld. The length of the resistant seam weld will indicate with the welding symbol be shown to the right of the welding symbol. B. The resistant seam weld extent for the fully distance between the abrupt change of the direction of the welding. No length of dimension needed to be shown on the welding symbol. C. When the resistant seam weld extends with less than the distance between the abrupt change of the direction of the welding, less than the full length of the joint, this extent will be dimensioned. Pitch of the resistant seam welds. The position of intermittent resistant seam welding will be shown the distance between the center of the welding increments and will be shown on the right of the length of the dimension. 5. Termination of intermittent seam welding intermittent resistant seam is used. The self symbol indicates the increment will be located at the end of the dimension line. When used, the continuous resistant seam welding symbol indicates the space is equal to pitch and minus the length of the increment will be left at the ends of the dimension length. The separate symbols will be used intermediate continuous resistance seam welds when there are two are used in the combination flush resistance seam welds. When the exposed surface of one more, the resistance seam weld is joined to be flushed. The surface will be indicated adding the flush or contour symbol. CC flasher upsets. Flasher upset welds have no arrow side or other significance in themselves other than supplementary symbols. Conjunction with them may have significance. The welding symbol of the flash upset welding centered with the reference line dimension will not be shown on the welding symbol. Two surface contour flash upset welds contours of the for the flash upset weld in the same manner as the fillet welds. For the conclusion, the task furnished with the explanation of the welding symbol and foreigner interruption in which, when actually performing welding procedures, TM 9237 should refer to the proper application.